All right, so we got another optimization problem here. So let's take a look at it. It says farmers can get $2 per bushel for their potatoes on July 1st, and after that, the price drops by 2 cents per day. On July 1st, a farmer has 80 bushels of potatoes in the field and estimates that the crop is increasing at the rate of 1 bushel per day. When should the farmer harvest the potatoes to maximize revenue? All right, so let's identify our variable and then let's come up with the function that we've got to maximize in this problem. All right, so I'm gonna let x, let me change the thickness on that. So I'm gonna let x equal the number of days after July 1st. Because they're asking when should the farmer harvest the potatoes. So the information they're giving us is based on July 1st, and so we're going to look to see how many days after July 1st we need to harvest the potatoes to maximize revenue. Now, we know that revenue is what? That's the price times the number sold. Okay. All right. So let's come up with the price and let's come up with the number sold. So in this problem, we'll have price. All right. So let's see what the price is. It says farmers can get $2 per bushel for their potatoes on July 1st. And after that, the price drops by 2 cents per day. All right, so the price here is going to be $2. And then after July 1st, each day after it drops 2 cents. So that's going to be minus 0.02 times x. So see, remember, x is the number of days after July 1st. So if x is 1 day after, then it's going to be 2 minus the 2 cents. If it's 2 days after, then it's going to be 2 minus, and 2 times 0.02, that would be 0.04, so minus the 4 cents, and so on. So that's how we represent the price. Now we need to represent the number of bushels that we sell. So this is going to be number of bushels sold. All right, so how many are we selling? Well, let's see. On July 1st, a farmer has 80 bushels of potatoes in the field and estimates that the crop is increasing at the rate of 1 bushel per day. So that's going to be the 80 on July 1st, and then every day after that, it's 1 times the number of days, okay? Because it's increasing at the rate of 1 bushel per day. So on the first day after July 1st, it would be what? 80 plus 1 times 1, which is 81. 2 days after, that would be 80 plus 1 times 2, which is 82, and so on. And so this is the number of bushels sold. So our revenue is equal to the price times the number sold. So that's going to be 2 minus 0.02x times 80 plus x. So there's our revenue function, and that's what we need to maximize. So I'm going to FOIL this out, combine like terms, and that ends up giving me the revenue is equal to negative 0.02 x squared plus 0.4x plus 160. And so now I want to maximize the revenue. So to maximize this, I'm going to take the derivative. So R prime is negative 0.04x plus 0.4. All right. And then we'll set this equal to 0. So that's negative 0.04x equals negative 0.4. And so that's x equals 10. And so what is that? That is 10 days after July 1st. So that's when he needs to harvest the potatoes to maximize his revenue. And look, you can plot the 10 here, choose a number on each side of it, and you'll see if you plug the 9 in, you'll be able to see that it's increasing here, decreasing here. Plug the 9 and the 11 into our derivative here, and you'll see positive, negative, so you'll see that this is a maximum. All right, so I hope this video helped. Check out my other videos. Give me a like, share, and subscribe, and thanks for watching.